Hey, good morning, everyone. All right, so today I'm going to talk about our new chapter, chapter 9, coordinate geometry. Right, so today we'll talk about the concept of coordinate geometry. So without further ado, let me go to the next slide. So over here, I have my x-axis and y-axis. They are both labeled, right? And next time when you see your x and y-axis, and this is actually called your coordinate geometry system. All right, we actually call this your coordinate geometry system. All right, so let me start off with plotting some points on this coordinate geometry system. All right, so let me start off with my -4 and 2. So this is my point C. Okay, you can actually also write down your these coordinates. Okay, by the way, the first is always your x coordinate, and followed by a comma here, and this is your y coordinate, and this x and y coordinates, okay, they form together to give you a point. Okay, therefore you call this is your point C. All right, so let me continue to plot another points. My 5 and 5. So 5 and 5 is here. Okay, so this is your 5 and 5. So let me call this point B. And last, and 8 and 6. 8 and 6 is here. So let me call this point A. Okay, so you have your these 3 points plotted out, and let me just use a straight line to link them up. Let me move up a bit. Okay, so yes, this is the one. Thicken it a bit. Alright, you choose a different color. No, it's alright. Blue is good. I like blue. Alright, okay, over here is it's not touching, so just make sure it touches all the points. Right? That's it. So now, what if you are asked to find the length of AB, BC, and AC? Okay? How are you going to find the length of AB, BC, and AC? Alright, I'm not going to ask you to memorize formulas. Okay, I know my students, if my students are asked to memorize formulas, they tend to forget very easily. Alright, so I would rather ask them to understand the concepts behind and try to make use of the understanding and figure out on the spot. Alright, so now I'm going to teach you how you can figure out the length of AB, BC, AC on the spot. Alright, so let me get a right angle triangle out first. Alright, so the technique here is, okay, if you are asked to find the length of AB, okay, the length of AB, so what you need to do is fit a right angle triangle such that your AB is the hypotenuse of the right angle triangle you fit. Right, so I hope you can see this is the right angle triangle that can fit. Okay, and AB is the hypotenuse. Okay, so with this right angle triangle, I can actually make use of our Pythagoras Theorem. Alright, so Pythagoras Theorem says a squared plus b squared is equal to c squared. Alright, am I right? And c is the longest side. Alright, so c is the longest side, so clearly c is our hypotenuse. Right? Denoted by capital H. So your job is to figure out what is your this. So it starts from 5 and it ends at 8. So this is 3 units, right? Alright, so what is this length of this? So it starts from 5, ends at 6, so it's 1 unit. Alright, so just sub in the value. So this is 3 square plus 1 square. So that's how you get your c square. And your c square is supposed to be 10. Therefore your c is plus square root 10 or minus square root 10. Alright, you have to reject your minus square root 10. Alright, because we are talking about a length. Okay, length cannot be negative value. Right, so reject your minus square root 10. Okay, and remember to write down this step. If not, you'll be penalized. Alright, therefore I get my length of AB, which is square root 10 units. Alright, so continue to do the same for BC. Right, so for BC, definitely you need a bigger right angle triangle. Okay, let me just test it first. Looks like this can be fit. Okay, we'll make it smaller actually. Alright, this is it. Alright, can you see? So to find the length of BC, so what you do is figure out what is this, right? And use Pythagoras Theorem. So this is minus 4 to 5, so it's 9 units. And over here is it start from 2, then ends at 5, so this is 3 units. Alright, so this is 3 units. So plug in the numbers. Okay, plug in the numbers, what do you get? So let me just make use of here. Alright, so since I'm not going to use, alright, let me just make use of the Pythagoras theorem once again. So this will be 9, this is 3, so c squared is supposed to be 81 plus 9, so it's 19. Alright, so you get positive 19 or negative square root 19. Alright, so you have to reject your negative value. Okay, it's kind of like troublesome to write this down but reject it. Sorry, you have to write it down, otherwise you'll be penalized. Okay, if you don't write this down, that means the teacher or the marker will think you have not even considered the negative value for C. Alright, so write this down but reject it. Okay, don't ignore this. Okay, so you have found your C, which is square root 90 units. Okay. Now your job is to figure out your AC, right? So pretty simple. Similarly, so let me make use of the Pythagoras theorem here. Alright, so for AC, right? AC, I'm talking about AC. Okay, so the base side is minus 4 to 8, that is 12. Alright, and we are talking about the length here, that is from 2 to 6, right? Yes, 2 to 6, right? So 2 to 6, that's 4. Alright, so this will give you c squared is equal to 160. Alright, yeah, and therefore your c is actually square root 160 minus square root 160. You got to reject your negative value, okay? Because we are talking about the length of a side. Alright, so AC is square root 160 units. Alright, okay, so with this, okay, so there is a very interesting question here. But before that, let me erase this first. Alright, okay, so the question is how do you prove A, B, and C, okay, they lie on a straight line? Okay, how do you prove this? How do you prove A, B, and C, they lie on a straight line? Okay, how do you prove these 3 points? They can form a straight line. All right. So the proof is, if you can prove your side AB plus your side BC minus your side AC is equal to 0, you can basically prove they lie on a straight line. Okay, you can actually prove they lie on a straight line. Okay, all right. So let's continue to prove. All right. Okay, so the concept here is, first you take your AB, okay, and then you plus your BC, okay, and you add them up. If the sum of these two minus your AC, and if you get 0, and then you can prove these 3 points ABC, they lie on a straight line. All right, so let me continue to see if this is valid. All right, I'm not too sure if it's valid, but continue. So AB is square root 10, this BC is square root 90 minus square root 160. So use your calculator, you get 0. Yep, so 0, right? Okay, so means this is valid. So once you can prove that this is valid, so therefore, by the way, this is a symbol for therefore in math. Therefore, A, B, and C lie straight line. All right, okay, and at the same time, you can actually see that from this graph, okay, they all start from point A, right? If you look at it, so you have your AB, you start from A. You have your AC, you start from A as well. Okay, so they start from the same point. Okay, so that's how you prove the 3 points are on the straight line. All right, pretty interesting, right? All right, okay, let me continue to make use of this this example, because I find that this example can actually give us a lot of insights. Right, so now, what about if we are asked to find the area of our this, let me call this point D. Okay, so point D is actually 5 and 2. All right, so to find the area of the triangle CD, okay, what you can do is you can use half times base times height. All right, so the base in this case is 9, and the height is actually our 3. Oh, by the way, I don't need a square here. So this, okay, the height is 3. So what do you get? So you are supposed to get 13.5 units square for the area of this triangle. All right. Okay. So this is the formula to find out the area of a triangle. We are so used to this formula since primary school, right? So today I'm going to introduce to you another method to solve area of this triangle CDB. All right, so I'm going to use the shoelace method, and I will show you why I call it a shoelace method. All right, so what you do is you write down half times. Okay, so you have a modular sign. All right, so this is a modular sign. Okay, two straight lines. All right, and you start from your, so let me just choose C as my starting point. All right, so if C is my starting point, so I have my minus 4 and 2, and I go to B, so it's 5 and 5, and then I come to D, 5 and 2, and the last pair of numbers will be given by my starting point, minus 4 and 2. Alright, So the idea is you start from C, okay, and then you go to another point, and then you go to another point, and then you come back to the starting point. All right, get it? Okay, the way you write it is you start with the x coordinate and then the y coordinate for each point. Okay, so once you get this, your job is half done. All right, so now what you need to do is you need to do some calculation. Okay, so let me continue to write down the modular sign. Okay, so what you need to do first is figure out the sum of the multiplication of the black arrows. All right, so the sum of them is given by -4 times 5, that is -20. All right, and plus 5 times 2 is 10, plus 5 times 2 is 10. Okay, so this will be the value given by the sum of the multiplication of the black arrows. All right, now so you minus another group of value. Okay, this group of value is given by, let me choose another color, you're given by this. So your job is to figure out the sum of the multiplication of all the red arrow. Alright, okay, so how do you do it? -4 times 2 is -8, plus 5 times 5 is 25, 5 times 2 is 10. Alright, so now your job is to simplify this. Alright, so you have half times absolute or modular sign, -20 plus 10 plus 10 is 0. So minus, then what do you have here? You will have -8 plus 25 plus 10, that will be 27. Okay, if you simplify it further, you get modulus -27. Okay, so let me briefly talk about the modular sign. Right, so let me go to the let me make use of the empty space here. So let's say if you have modulus 3. Okay, so this is a modulus, right? Modulus. So if you have modulus 3, so you will get 3. If you have modulus -2, you will get 2. Okay, so the modular sign will force the value inside the modular sign to be positive. Okay, if you have a positive value inside, you will get the positive value. Okay, if you have negative value inside, you will get the positive value of that value. So modulus 3, you get 3. Modulus -2, you get 2. So what if you have modulus -1? So modular sign will make this -1 positive, right? So get 1. Right? So that is the function of the modular sign. So for this case, you have like modulus -27, so you will get 27. And then for this half times 27, you will get 35 units squared. So can you see that this so-called the shoelace method, okay, it looks like a shoelace, right? Okay, so the shoelace method here to find the area of the triangle is a 13.5 unit squared, and compared to your this 13.5 unit square, I hope you can appreciate they are the same. Alright, and that means you can either use your this half times base times height, or you can also use the shoelace method. Of course, you might be thinking, why do I need to use the shoelace method? Because the shoelace method is so complicated, right? And sometimes it can be quite manually intensive, alright, if you have too many pairs of numbers. But the beauty of the shoelace method is you don't have to find the base and the height. Okay. Sometimes the base and the height is not so clear, the question. Okay, so if they are not so clear, I think it's easier to use the shoelace method. But I leave that to you. Okay, I leave that to you. Which method you want to use is up to you. But I just want to share with you, you have another tool to find out the area of triangle. Alright, so with this, I'm going to conclude here. Thank you for watching my video. And if you really love my videos, please subscribe to my channel and you will get updates regularly. And of course, please share my videos with those who might need it more than you do. Okay, so thank you once again. Bye bye.